Okay, we're supposed to find sine and cosine of some different angles without using a calculator, and we want these to be exact values. So you'll notice that we have sine of negative 7 pi over 2. Now, as we get going on this, I notice we have a negative angle. It'd probably be best if we find a coterminal angle to negative 7 pi over 2 that's within 0 to 2 pi, like the first time around the circle. So to do so, we'll take negative 7 pi over 2, and we're going to add 2 pi to this. So as we're thinking about adding 2 pi to it, let's strategically write that 2 pi. So we want to have the same denominator as the fraction that we already have. So instead of writing that as plus 2 pi, I'm going to think I want to have a 2 in my denominator, just like the first fraction. Well, 4 halves is the same thing as 2 pi. All right, now as we combine these together, we end up with negative 3 pi over 2. Still not quite where we want to be, so we're going to try it one more time. So we're going to start with negative 3 pi over 2, and we're again going to add 2 pi, but strategically write it so it has that same denominator. So this is going to be pi over 2. And that pi over 2 is coterminal with negative 7 pi over 2. So this is actually the exact same as sine of pi over 2. Coterminal angles, their sides land in the exact same position as one another. So their terminal side will be lined up for coterminal angles. All right, let's do the same thing with cosine, and then we'll talk about how to evaluate these without using a calculator based on the unit circle over on the right-hand side. So I'm going to start with 5 pi over 2, but this time it's too big, all right? 4 pi over 2 is 2 pi, so we want it to be within 0 and 2 pi. So this time to get a coterminal angle, we're going to subtract 4 pi over 2, because that's like subtracting one time around the circle, same thing as subtracting 2 pi. And this one also works out to be pi over 2, 1 pi over 2. So cosine of 5 pi over 2 is equal to, cosine of pi over 2. All right, now let's talk about how do we evaluate this without using a calculator. So let's think about our unit circle. For it to be a unit circle, each one of these is of length 1 to get out to from the origin all the way out to the points on the circle. And I've gone ahead and listed our quadrantal angles. So pi over 2, pi, 3 pi over 2, and then 0, or that's kind of equivalent, it's coterminal with 2 pi. All right, so to get to out to the right 1 unit, if our angle happened to be out here, that's right 1 unit, 0 units up or down. Pi over 2 is going to be 0 units left or right, 1 unit up. Out all the way to the left, out at pi, that ordered pair is going to go 1 unit to the left, 0 units up or down. And then finally, if we had gone 3/4 of the way around the circle to 3 pi over 2, that's going to be the ordered pair 0 left or right, down 1 unit. So we have our quadrantal terminal points. The last thing to remember is that with these terminal points, it always goes cosine is like the x value, and sine is going to be the y value. So on both of ours, we're really focused on the top of the circle at pi over 2, because that was our coterminal angle that we found. So evaluating sine of pi over 2, that's going to be the y value. So this is going to equal 1. And then cosine of pi over 2 is going to be the x value. That's going to equal 0. So you can do the same thing no matter what quadrantal angle you got. Just focus on, you know how to do ordered pairs. Did I go up or down, left or right? 1. And write out the ordered pairs. Remember, it's always cosine, then sine when you're getting these terminal points. All right, hope this helps.